This video is an introduction to event-driven architecture, explaining how event-driven systems enable real-time big data processing and analytics. Let's start. So, what exactly is event-driven architecture? It's a system design approach that focuses on events triggering actions. Components communicate asynchronously, enhancing responsiveness and scalability. The core concepts involve events as signals of state changes, event producers and consumers, and event brokers and message queues. Event-driven systems consist of producers, consumers, and event brokers that facilitate asynchronous communication and real-time processing. An event producer generates the events. The event broker or queue receives and routes these events. And finally, the event consumer processes these events. Event-driven architecture offers several key benefits, including real-time data processing and responsiveness, improved scalability through asynchronous communication, loose coupling between system components, and enhanced fault tolerance and reliability. Some use cases for event-driven architecture include real-time analytics and monitoring dashboards, Internet of Things device event management, notification and messaging systems, and fraud detection in financial systems. Here is a sample Python code for an event consumer. It has a function called handleEvent which takes the event as the argument. Inside the function, if the event type is data update, process data function is called with the event payload. Another conditional check is done to see if event type is alert. Send alert function is called with the event payload. Next, we define a function called consumeEvents which takes the queue as the argument. Inside a while true loop, we get the event from the queue and then we pass the event to the handleEvent function. Challenges of event-driven architecture are managing event ordering and delivery guarantees, debugging distributed asynchronous communication, handling event duplication and idempotency, and scaling event brokers under high load. The mitigation strategies are the use of durable message queues and acknowledgements, implementing idempotent event handlers, centralized monitoring and tracing tools, and partitioning and sharding event streams. Event-driven architectures process streams of data instantly, allowing analytics platforms to respond in real time. This capability enables timely insights, improved decision-making, and adaptive big data workflows. In summary, event-driven architecture accelerates real-time big data processing by enabling asynchronous, scalable, and resilient system designs. It supports rapid analytics and adaptive responses, essential for modern data-driven applications. Thank you for your attention. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.